Hi class, in this video we're going to be doing the Foundational 15 for Chapter 2. So I'm doing this right out of Connect, and I have a little bit of whiteboard space here to the right where I'll be doing the work. Okay, so for this one, when you're doing it within Connect, it only lets you do one problem at a time, so we'll go one at a time here, and as we're doing these problems, make sure to make note and keep track of all the answers, because a lot of these answers are needed for later questions. Okay, so let's take a look here. We're looking at Sweeten Company had no jobs in progress at the beginning of March and no beginning inventories. The company has 2 manufacturing departments, molding and fabrication. It started, completed, and sold only 2 jobs during March, Job P and Job Q. The following additional information is available for the company as a whole and for jobs P and Q. All data and questions relate to the month of March. So they break it down between the molding and the fabrication department. So they tell us the estimated total machine hours that would need to be used in each department and in total as well, and the estimated total fixed manufacturing overhead that they think would be incurred in each department during the month of March, and also the estimated variable manufacturing overhead per machine hour that would be incurred within each department in the month of March. And then it also gives us some information for Job P and Job Q. So it tells us the direct materials and direct labor cost actually incurred on each job, and also the actual machine hours used on each job within each department. It also tells us that Sweeten Company had no under-applied or over-applied manufacturing overheads costs during the month. Okay, so these questions are actually split into 2 clusters or 2 chunks. So for questions 1 through 9, we're going to assume that Sweeten Company uses departmental predetermined overhead rates with machine hours as the allocation base in both departments. And Job P included 20 units and Job Q included 30 units. So for 1 through 9, we're using a departmental predetermined overhead rates, 2 of them. 1 for molding, 1 for fabrication. But for questions 10 through 15, we're assuming that the company uses a plant-wide predetermined overhead rate with machine hours as the allocation base. So we'll be doing all the questions 1 through 9 using 2 pours, and then in 10 through 15 answering those same questions but using a different pour for the entire company. Okay, so let's start here. So first question asks, what were the company's predetermined overhead rates in the molding department and the fabrication department? Okay, so we're finding the 2 departmental pours here since there's 2 departments. So we want to remind ourselves what it means to calculate a pour. So remember, direct materials and direct labor, those kinds of costs are easily traceable to a job. We know exactly how much of those elements are spent on each job. But when it comes to manufacturing overhead, that's not a very easily traceable cost. So instead, if we can't trace, we allocate the cost using a predetermined overhead rate that we determine at the beginning of a period. So how do we find a pour? We have to remember how to calculate pour. And remember, pour is calculated by taking the total estimated manufacturing overhead divided by the total estimated activity. So whether it's departmental pour or plant-wide pour, it's the same thing. But if it's a departmental pour, so if we're looking at one department molding, it'll just be the estimated overhead within the molding department and the estimated activity within the molding department. And then we do the same for fabrication. But if it's a plant-wide pour, it's just overall for the entire company. So let's first find the molding department's predetermined overhead rate. But in order to do so, we're going to actually need to first estimate the total manufacturing overhead that the company estimates will be incurred within that department within March. So I can't take my highlighter over to the left, unfortunately, but we can see here within the molding department, the fixed overhead that they estimate will be incurred in that department is $10,000. And the estimated variable manufacturing overhead per machine hour is $1.40. So we need to find out what those 2 are combined as a total dollar amount. Okay, so because in order to find the pour, we need the total estimated manufacturing overhead at the top, and we don't know that total yet. So we can start here. We know the fixed manufacturing overhead is $10,000 that they estimated for within the molding department. But the variable manufacturing overhead, we actually need to calculate. So they estimate it to be about $1.40 per machine hour. And how many machine hours did they estimate will be used in the molding department? 2,500 machine hours. So we'll multiply these two together to see what the estimated variable manufacturing overhead is. So we'll take the $1.40 times 2,500 machine hours to see that the estimated variable overhead to be incurred in the molding department is $3,500. Okay, so we have the fixed element and the variable element. So we will now add these together, and essentially we're using that cost formula, y equals a plus bx. Okay, so this a is the fixed portion, and this bx is the total variable portion, and where y is the total estimated manufacturing overhead. So A is the $10,000 plus the estimated variable portion of overhead to be incurred within the molding department of $35,000. So what's the total estimated manufacturing overhead to be incurred in the molding department? Well, $10,000 plus $3,500 is $13,500 of manufacturing overhead. There we go. Okay, so now we have enough to further our pour calculation. So we'll go back to the molding pour. And remember, the pour, any pour is defined as the total estimated manufacturing overhead, which we just now found to be $13,500 for the molding department. That's how much overhead we think would be incurred within that department. And the estimated activity, the total amount of the allocation base, they're using machine hours in this case. The total estimated machine hours they estimate we'd use in the molding department is 2,500 machine hours. So basically what that's saying is we're estimating that going into March, we'll use 2,500 machine hours in the molding department, costing us about $13,500 in manufacturing overhead within that department. So we'll take that total estimated manufacturing overhead within that department divided by 2,500 machine hours. That gives us $5.40 per machine hour for our overall molding pour here. All right, so we already know one of them. So I'm going to add into the molding department $5.40 for that pour. But now we will do the same thing, but for the fabrication predetermined overhead rate. Let me switch pens here. Okay, so same approach here, but different department. Okay, so we'll do the fabrication pour. So the estimated fixed manufacturing overhead within the fabrication department, they tell us that is $15,000. Now we need to find the variable portion of the estimated overhead to be incurred within that department. Well, they estimate it's going to cost about $2.20 per machine hour in terms of variable overhead within that department. But how many machine hours do they estimate will be used within that department in March? 1,500. That means the total estimated variable manufacturing overhead that they estimate within the fabrication department is $3,300. So with that in mind, what's the total estimated manufacturing overhead to be incurred in the fabrication department? Remember the y equals a plus bx, right? A meaning the fixed portion, which is the $15,000, plus the total variable portion bx, which we now found to be $3,300. We add that together, that gives us $18,300 of total estimated manufacturing overhead. Okay, now we can use that to find our fabrication department's pour. Now, how do we do that? We take the total estimated overhead to be incurred in that department of $18,300 and divide that by the total estimated number of machine hours in that department, which is 1,500. What does our pour come out to? that 15, and we'll divide that 18,300 by 1,500 machine hours, and that gives us $12.20 per machine hour for our fabrication department pour. Okay, very good. So we'll plug that in here. Let's go ahead and score this answer. And it'll take a second. There we go. And that is good to go. So since I'm going to have to move to clean workspace here for the next problem, please make note of what your pour is for the molding department and for the fabrication department. We'll need that in the next problem. Okay. So I'm going to scroll down here a little bit as we move on to the next question. So the next question asks, how much manufacturing overhead was applied from the molding department to job P and how much was applied to job Q? Okay, so we're going to take that molding department pour. Remember that was what? $5.40 per machine hour. So that's what we want to use now. So for each job, for job P and job Q, we know for both how much direct materials and direct labor costs we've incurred, but we don't know the manufacturing overhead. We need to apply that. So we want to first, since the overhead comes from two departments, molding and fabrication, we're first figuring out how much of the molding department's manufacturing overhead to assign to job P and job Q. So we'll start with job P. Okay, and actually before I start with job P, let's write out how to apply overhead to a job. So I'll do apply manufacturing overhead. What's the calculation for that again? Remember, you take your pour times the actual level of activity. Okay, so that's the application of overhead formula that we'll be using throughout this class when we apply overhead. Okay, so now we're going to start with job P and figure out how much of the molding department's manufacturing overhead to apply to this job. So we'll follow this formula. So we'll start with the pour from the molding department. That's $5.40 per machine hour. We're going to multiply that by the actual machine hours used by job P within the molding department. So we can look here in job P to the left in this table. Job P here used 1,700 hours within the molding department in actuality during the month of March. Okay, so we'll multiply those two together. $5.40 times 1,700. That gives us $9,180 of molding manufacturing overhead applied to that job. And we'll do the same for job Q. So job Q, again, start with the molding department pour, $5.40 per machine hour. But now we're going to see, okay, how many hours did the job Q actually use within the fabrication department? Job Q actually, or not fabrication department, sorry, molding department. Job Q actually used 800 hours within the molding department. And our estimate, again, is that for every machine hour used within the molding department, it's costing about $5.40 in overall manufacturing overhead. So we'll take that $5.40 times 800 machine hours. It gives us $4,320 of molding department's manufacturing overhead to be applied to job Q. In other words, that's how much we're estimating job Q is responsible for of all of the molding department's estimated manufacturing overhead costs. So of the overall estimated overhead incurred by the molding department for March, we're saying that $9,180 of that is assigned to job P and $4,320 of that is assigned to job Q. So let's score that answer. Give it a second. There we go. Now we can move on to the next question here. Similar question, but how much manufacturing overhead was applied from the fabrication department to both job P and job Q? We've now found how much of the molding department's overhead to divvy up between the two jobs. Now we're going to do the same with the fabrication department. But remember, using departmental pores, the fabrication department has a different pore, right? Let's write that out here. So we have a fabrication department pore. Remember, that was $12.20 per machine hour. Okay, so I'm going to do the same exact thing here, just for the fabrication department, figure out how much of its overall estimated overhead to be broken up between the two jobs. So remember, how do we apply overhead? We take up the pore times the actual level of activity. So we'll start once again with job P. Okay, we start with a pore of $12.20. So with the fabrication department, every machine hour on average, based on the estimations, is costing about $12.20 in overhead. So then given that, how many hours did job P actually spend within the fabrication department? Job P actually used 600 machine hours within the fabrication department. So what's the estimated manufacturing overhead cost to be applied to job P? We'll do $12.20 times 600 machine hours. That's $7,320 of estimated applied overhead from the fabrication department. We'll do the same with job Q. Same pore, since we're applying overhead from the fabrication department, but how many hours did job Q use within the fabrication department? 900 machine hours. And if each machine hour is costing on average about $12.20 of overhead within the fabrication department, the total overhead to apply to job Q from the fabrication department is about $10,980. All right, so let's add this in. Of the overall estimated overhead from within the fabrication department, $7,320 of it is estimated to be applied to job P, and $10,980 of it is estimated to be applied to job Q. So let's go ahead and score that answer. There we go. Perfect. On to the next question. Okay, what was the total manufacturing cost assigned to job P? Okay, so when we look at the cost of a job, and any product for that matter, anything that we're manufacturing, the cost of a job is made up of what? It's made up of direct materials, direct labor, and manufacturing overhead. So if we were to look at job P, we know the direct materials, right? The direct materials spent on job P is $13,000. What about direct labor? The direct labor spent on job P is $21,000. That's given to us, right? We keep track of that. But what about manufacturing overhead? It comes from two sources with a departmental pore, right? There's molding overhead and fabrication overhead. We're not combining the two into one. So how much overhead did we apply to job P from the molding department? That was the $9,180, right? So that's molding manufacturing overhead. And then how much was applied to job P from the fabrication department? That's the $7,320. So if that's all the costs associated with job P, we're going to add it all together to see what the total manufacturing cost is of job P. Take the $13,000 plus the $21,000 plus $9,180 plus $7,320 for a total cost of job P of $50,500. So that's the total cost of job P. Okay. Let's add this in here, $50,500, and we'll score our answer. There we go. Perfect. On to the next question. So number 5 takes this a step further. So it asks us, now we know what the total cost is of job P, but if job P included 20 units, what was its unit product cost? So what would be the cost of each unit within job P? Okay, because remember, with a job consists of homogeneous units. So whether there's one unit in a job or 1,000 units, they're all the same within a job. So if the cost of the entire job is $50,500, we're going to divide that by 20 units to figure out what each unit individually cost us to make within that job. So we're just going to take that $50,500 and divide it by 20 units. So that gives us $2,525. So that's on average, the cost of making one unit within job P's specifications. So let's plug that in and let's score our answer. There we go, that's correct. So now we can move on to question number 6. All right, so this question is asking us, what was the total manufacturing cost associated or assigned to job Q? Okay, so we'll do the same we just did here for job P. Okay, so job Q. Again, it's also made up of direct materials, direct labor, and manufacturing overhead. So direct materials, we know how much direct materials we spent on job Q. That's $8,000. That's given to us here. And in terms of direct labor, we spent $7,500. And now we already know how much molding manufacturing overhead was assigned to the job and how much fabrication overhead. So if we go up to the top, remember we see that the amount of molding department manufacturing overhead assigned to job Q is $4,320. And the amount of fabrication department manufacturing overhead applied to job Q was $10,980. Okay, so we'll do $4,320 for molding department's manufacturing overhead applied, and then $10,980 for the fabrication department's manufacturing overhead applied. So we're going to add all of these together to find out what the total cost was of manufacturing job Q during the month of March. So we'll take the direct materials plus the direct labor plus the $4,320 of overhead applied from molding and the $10,980 of manufacturing overhead applied from the fabrication department. So overall, we can see here that the estimated total cost of job Q is $30,800 here. Very good. Let's score that answer. There we go. That is correct. On to number 7. So number 7 asks us, if job Q included 30 units, what is its unit product cost? So same thing we did before. If the entire job here cost us $30,800 to produce, and it consists of 30 homogeneous identical units, then what is the cost of each of those units? Okay, so we'll just take the $30,800 and divide that by the 30 units within the job. So that rounds to $1,027 per unit. Okay, so that's the cost of producing one unit within job Q. So we'll do 1,027 here. We'll score our answer. There we go. Very good. And I also encourage you can pause this video at any time and rewind as necessary. So don't hesitate to do that. Okay, on to question number 8. Number 8 asks us the following. Assume that Sweeten Company uses cost plus pricing and a markup percentage of 80% of total manufacturing cost to establish selling prices for all of its jobs. What selling price would the company have established for jobs P and Q? What are the selling prices for both jobs when stated on a per unit basis? Okay, so we've now, for both of these, we found the cost of each job in total and per unit. So what we want to do is figure out how much we should be selling these jobs for in order to make the necessary profit. So the markup here is 80%. So what exactly does that mean? So that means that we want to be selling these jobs for a price that reflects 100% of its cost plus 80% of its cost. So we want to make 80% of its cost in profit. So to illustrate, let's look at job P first. We'll take a different color here. So we'll do job P, selling price. Okay, so for job P, what is the overall cost of job P? We determined that to be $50,500, right? Well, we want to mark that cost up by 80% to determine what to sell it for. So how do we find, or how are we going to do that math problem? So I always do it as follows, and this is how I teach it. You can do it the longer way as well, but this is the quicker way to do it. So when you have a markup, to figure out what to multiply that cost by, you always start with 1, and that 1 represents 100% of the cost. So when you determine a selling price, you at least want to cover 100% of the cost, right? But to that, you'll add the markup, and the markup here is 80%, and you'll do that markup in decimal form. So we'll do 1 plus 0.80, and that gives us 1.8. So we're going to multiply that cost by 1.8, which is 180% of the cost is what we want to sell it for. So in our calculator, we'll do 1.8 times 50,500. So that means we want to sell job P for $90,900. So that's the selling price here that we want to assign to job P. Okay, but they also ask us, well, what if you were selling not the entire job, but each unit within a job on its own? Well, we do the same thing. What does each unit cost within job P? Costs us $2,525, and you'll do the same thing. You'll multiply that by 1.8 as well. So we'll do 25 times 1.8. That means each unit should be selling for $4,545 for that desired level of profit. You could also have taken the $90,900 overall selling price of the job and divided that by 20 to get the same answer as well. So we can add that in. So the selling price of job P should be $90,900, and the selling price per unit within job P is $4,545. And to illustrate where I'm getting that 1.8 from further, we could have also done, if we know the markup's 80%, we could have started with the 50,500 times 80% to figure out what the markup is. So the markup on the cost is 40,400. So you want to add that markup to the initial cost, and that gives us the same answer. So you can do it that way as well. Okay, so now we'll do job Q, find its selling price. Okay, so we know what the overall cost is of job Q, right? That was the $30,800 that we found. And its markup is also 80%, so we want to multiply that by 1.8 to figure out what we should be selling that job for. So 30,800 times 1.8 is $55,440. So that's what we want to be selling the entire job for. But if we're selling it unit by unit, we want to know what to sell each unit for. What was the cost of one unit within job Q? $1,027, right? So we can also multiply that by 1.8 to figure out what we should be selling each unit for. So 1,027 times 1.8 gives us 1,849. And another thing we could have done is taken the 55,440 and divided that by 30 units to get the same answer. So we have a slight rounding error here. So we'll stick with 18,848. Okay. All right. So we know that we would be selling job Q for $55,440 with that given markup, or $1,848 per unit. And it says do not round intermediate calculations here. We would have wanted to go from the total selling price of the job divided by 30 to get that answer there. So let's go ahead and score our answer. Very good. Perfect. On to the next one. So here we have number 9. So this question is asking, what was Sweeten Company's cost of goods sold for March? Okay, well, what is cost of goods sold? It's the cost of the goods we sell, right? And if we look here, remember at the beginning they tell us that the company started, completed, and sold the 2 jobs. So by the end of March, both jobs P and Q were sold. So there was no leftover inventory. They sold everything. So how do we find the cost of goods sold then if we know we sold both jobs? Well, we simply look at the cost of both jobs. We know the cost of job P, right, which is the $50,500, and we know the cost of job Q, $30,800. So if we sold both jobs, the cost of goods sold should just be the cost of the 2 jobs added together. We add the cost of those 2 jobs together, we get $81,300. Score that answer. There we go. Okay, so we simply added the cost of the 2 jobs together to find the cost of goods sold because we are told that we sold both jobs. All right, so now we've finished the first batch, questions 1 through 9. Now we're going to do all of the questions again, assuming not that we're using 2 departmental predetermined overhead rates, but instead that we're using a plant-wide predetermined overhead rate. So we're not then splitting it up between departments, but looking at it from a company-wide perspective. Okay, so with number 10, we're starting over, clean slate, and using a plant-wide pour. So number 10 is asking us, what was the company's plant-wide predetermined overhead rate? Okay, so the way in which we calculate pour, that doesn't change, right? The fundamentals don't change. So remember, pour is still going to be your total estimated manufacturing overhead divided by your total estimated activity. The only difference here is that with a plant-wide predetermined overhead rate, that's estimated overhead for the entire company and estimated activity for the entire company, where when we were doing the plant-wide overhead rates for molding and fabrication, we were doing the pour for each of them on their own, finding the overhead, estimated overhead for molding and estimated overhead for fabrication separately. Okay, so we're going to start with our calculation here. So we first want to find the total estimated manufacturing overhead for the company as a whole. We already know the total fixed manufacturing overhead for the company as a whole. That is, we have it for molding and fabrication. Remember the 10,000, the 15,000, but we're going to add that together to say for the entire company, the estimated fixed overhead is $25,000. But remember, manufacturing overhead is made up of both fixed and variable elements. So we need to find the variable manufacturing overhead that we estimated for the company as a whole. Okay, so it's these two added together give us the total estimated manufacturing overhead. But here they give us the estimated variable manufacturing overhead per department here, per machine hour. So to find the variable manufacturing overhead, we'll first start with the molding department. So on average, they're estimating that it would cost about $1.40 per machine hour within the molding department. And how many machine hours were used within the molding department? 2,500. And we already did this calculation in the earlier batch, but we'll do it again. So $1.40 times 2,500, that's 3,500. And then for the fabrication department, it's $2.20 per machine hour, and the estimated machine hours in that department is 1,500 machine hours. So we'll do $2.20 times 1,500 machine hours, and that's 3,300. So the total estimated variable manufacturing overhead to be incurred for the company as a whole, that comes out to $6,800 of variable manufacturing overhead. There we go. And another way you could have done this is applied the cost formula to each department on its own like we did before. Find the total estimated overhead within the molding department, and then within the fabrication department, add the two together, and we would get the same answer that we're working towards now. So now we found the variable manufacturing overhead that we estimate for the company as a whole, and we know the fixed element. So now we can add them together. So the estimated fixed manufacturing overhead for the company, that's $25,000, plus the variable manufacturing overhead for the company, that is $6,800. So when we add them together, what do we get? That comes out to $31,800 of manufacturing overhead we estimate to incur for the company as a whole amongst all departments. Okay, so now we can plug in to that POR calculation, right? So remember, our POR is our total estimated manufacturing overhead divided by our total estimated activity. So we know our total estimated manufacturing overhead for the company as a whole. We're going to divide that by the total estimated activity, where the chosen allocation base here is machine hours. So how many machine hours do we estimate will the company use as a whole in March? 4,000, right? The 2,500 within molding plus the 1,500 within fabrication gives us 4,000 machine hours for the company as a whole. So what do we get for our POR? We're going to divide that estimated overhead by 4,000 machine hours. That gives us $7.95 per machine hour for our plant-wide POR. And what does this translate to? This essentially just translates to the fact that on average, our estimate here is that for every machine hour used within this company, it's going to cost us about $7.95 in terms of manufacturing overhead overall. All right, so let's add in that $7.95, score our answer. It'll take a second. There we go. Very good. On to the next question. All right, let's see what number 11 is asking us. How much manufacturing overhead was applied to job P and how much was applied to job Q? So now we're going to use this POR that we found to see how much overhead would be applied to job P and job Q. So now the difference is we're not doing it department by department. We're just taking all of the estimated overhead for the entire company for the period, this $31,800, and proportionately divvying that up between the two jobs based using this POR that we just calculated here, the $7.95. Okay, so we'll start with job P. Okay, so how much overhead are we going to apply to job P? Well, again, what's that calculation for the application of POR? Let's start with that once again. We want to remind ourselves. So to apply manufacturing overhead, we're going to take our POR and multiply that by the actual level of activity. Okay, so that's how we apply manufacturing overhead to a job. We take the POR and multiply it by the actual level of activity. Okay, so we'll start with job P. We know the POR, right? We're using a plant-wide POR here of $7.95 per machine hour. So we just need to know what's the actual level of machine hours that job P used within the month of March. We know that, right? So job P used 1,700 hours within molding and 600 machine hours within the fabrication department for a total number of machine hours of 2,300. So job P used 2,300 machine hours during the month of March to get completed. So how much overhead should we apply to that job? We'll take $7.95 times 2,300. That gives us $18,285 of manufacturing overhead to apply to job P. Now we will do the same to job Q. Okay, so we'll take that POR once again of $7.95 and multiply it by the amount of machine hours that job Q actually used in the month of March to reach completion. And that's 1,700 machine hours according to our chart here. Because job Q used 800 machine hours within the molding department and then 900 machine hours within the fabrication department. So we'll do $7.95 times 1,700 machine hours, and that's $13,515 of manufacturing overhead applied to job Q. Very good. So let's add these numbers in. There's $18,285 of overhead applied to job P, and then $13,515 of overhead applied to job Q. And just for illustration's sake, I'm going to take that $13,515 and add that to the overhead applied to job P of $18,285. When we add those two together, we get the $31,800 of overall estimated overhead to be incurred for the entire company. So all we've done once again is take that overall overhead that we estimate the entire company will incur, and we broke it up between the two jobs that work was done on for the period. Let's score our work. There we go. Very good. We'll go on to number 12. Number 12 asks us, if job P included 20 units, what is its unit product cost? Okay, so to find that, we first need to determine what the total cost is of job P. So job P's cost is made up of direct materials, direct labor, and overhead, right? So we know the direct materials cost incurred on job P is $13,000. The direct labor cost is $21,000. And then the overhead applied, which we just determined, is $18,285. So we add those together to find the total product cost of job P. So that's $13,000 plus $21,000 plus $18,285. That's total product cost of $52,285 for the entire job. Now, this question is asking us, however, not what the total cost is of job P overall, but what the cost would be of each unit within job P. So how do we do that once again? We just take the total cost of the job, right, and divide it by the number of units within that job, which they're telling us is 20 units. So what does the total cost per unit come out to? We're going to divide that cost of $52,285 by 20 units. We'll round that to the nearest dollar. That's $2,614 per unit. So on average, that's what each unit within job P was costing us to produce. So $2,614. Let's score that answer. There we go. Question 13. If job Q included 30 units, what is its unit product cost? So we'll do the same thing, right? We first need to find the total cost of job Q. Well, the cost of job Q would consist of its direct materials, direct labor, and applied overhead. The direct materials spent on job Q in the month of March is $8,000. The direct labor spent on job Q is $7,500. And the overhead we applied to job Q just now using the plant-wide pour is $13,515. We're going to add all of that together to find the total cost of job Q. We'll do 8,000 plus, let me do that again. We'll do 8,000 plus 7,500 plus 13,515 for a total cost of job Q of $29,015. So, but again, this question isn't asking what the total cost is of job Q overall, but what the cost is of each unit within job Q, right? So we're going to just take that $29,015 of total cost of job Q and divide it by the 30 units within that job to find the cost per unit. So that rounds to about $967 per unit. Okay, very good. Enter that and let's score our answer. There we go. On to our second to last question. We're almost there. Number 14 asks us, assume that Sweeten Company uses cost plus pricing at a markup percentage of 80% of total manufacturing cost to establish selling prices for all of its jobs. What selling price would the company have established for jobs P and Q, and what are the selling prices for both jobs when stated on a per unit basis? So we're going to do the same we did before, right? We know now how to calculate the selling price of a job based on the markup given. So for job P, what's its total cost? Its total cost is $52,285. The markup in here again is 80%, so we're going to multiply that by 1.8 to figure out what to sell the job for overall. So we're going to take that cost of $52,285 times 1.8, so we should be selling this job for $94,113. But what would that work out to per unit? Well, we can take that per unit cost here and multiply it by 1.8, or we can take that 94,113 and divide that by 20 units to see what we should sell each unit for. So we can divide that by 20, and that would round to $4,707 per unit for this selling price for each unit within job P. Now, what about job Q? Same process, right? We already did all of the work to know what the cost is of job Q overall and per unit. So we can take that cost of job Q of $29,015, multiply it by 1.8 to see what we should sell this job for. So $29,015 times 1.8, that comes out to a selling price of $52,227. That's for the job as a whole. Now, if we want to know what to sell each unit for, we can take that total selling price of $52,227 and divide that by 30 units. And then we get $1,741 per unit for our selling price. What else could we have done? We could have also taken that cost per unit of $967 and multiplied that by 1.8 to get the same answer. All right, so based on a markup percentage of 80%, we should be selling the entire job for $52,227, or be selling each unit for $1,741. Let's score that answer. I must have entered that incorrectly. Let's double check our work. We'll do the 94,113, divide that by 20 units. Oh, that's 4,706. Okay, so that is just a rounding error on my part. So that's 4,706 for the selling price per unit of job P. But since I already scored my answer, I cannot fix that. All right, so we'll go on to the last one. What is Sweeten Company's cost of goods sold for March? Okay, so once again, they said we sold both jobs, right? Both jobs completely. There's nothing left. No ending inventory. We sold both jobs. Well, then how do we find the cost of goods sold then? Well, if we sold both jobs, the cost of goods sold for March is simply the cost of those two jobs that we sold, right? Well, the cost of job P is $52,285, and the cost of job Q is $29,015. To find the cost of goods sold, we would simply just add these two together. So we'll do $52,285 plus $29,015. When we add that together, we get $81,300. Now, doesn't that seem like the answer we had for number 9 when we found the cost of goods sold when using the departmental overhead rates? Yes, it is. And how can that be? Well, remember, regardless of whether we use departmental overhead rates or plant-wide overhead rates, the costs incurred and the estimated cost incurred for the company as a whole didn't change. The only difference between 1 through 9 and 10 through 15 is how we divvied up those costs between job P and job Q. So at the end of the day, regardless of how the costs were divvied up, if you sold both jobs, all of those costs would have anyways flowed through to cost of goods sold. So since we sold both jobs, the cost of goods sold overall is still $81,300. So we'll score our question here. There we go. And that is it for the Foundational 15 for Chapter 2. I would recommend after you've watched this video and done this along with me, when you're ready, go ahead and open up a fresh Chapter 2 Foundational 15 within Connect and try all of these problems on your own. Good luck with Chapter 2.